about the module seatbelt warning system using basic and NOT gate. For that, open Google and search virtual labs in the search bar. Click on the electronics and communications option. Scroll down and click on the digital applications lab. So this is the page where all the contents are available regarding our module and any other modules which can be accessed at any time and at any place. Click on the list of experiments. Now we are going to learn about the module seatbelt warning system using basic and NOT gates. The aim is to study the applications of a combination of and NOT gates in a seatbelt warning indicator. The user will be able to construct, simulate and verify the seatbelt warning application using the generalized simulator and display the output on red LED. The combinational logic circuit is the interconnection of logic gates to generate a specified logic function where the input results in an immediate output. This can be easily understood by the following example. The following English expression describes the way a logic circuit should operate in order to drive a seatbelt warning indicator in a car. If the driver is present and the driver has not buckled up and the ignition switch is on, then the warning light should turn on. The Boolean expression for this application can be written as warning light equal to driver present not buckled up bar dot ignition on. This can be written as W equal to D dot B bar dot I. This expression can be easily implemented by using a single 3-input AND gate along with a single NOT gate. This expression could also be implemented by multi-level logic wherein one gate drives another gate. In general, we may use two dual-input AND gates and a single NOT gate. Student needs to be cautious and judicious while selecting the gates. As the number of level increases, the response time of the circuit also increases. Multi-level logic leads to the introduction of more time delay as compared to the single-level logic with multiple inputs. If it takes t seconds for a gate to respond to a change in its input and that gate drives a succeeding gate, then it will take 2t seconds for the entire circuit to respond. It is desirable to minimize the number of levels in the logic. If one needs to construct a truth table for the same, it can be easily prepared by entering ones and zeros in that expression for various input combinations. This is the truth table for the given module. Applications. A seatbelt is a safety feature installed in modern vehicles to protect the occupants in case of an accident. However, in some instances, the occupant may start driving the vehicle without fastening the seatbelt. This may lead to the violation of safety rules as well as pose risk to the occupants. To indicate that the seatbelt has not been buckled while the ignition switch is turned on, the AND NOT based indicating system provides a good solution. When the driver turns on the ignition switch without fastening the seatbelt, then the warning light glows. This indicates that the seatbelt is not buckled or fastened. The figure 1 indicates the 2-level logic and the figure 2 indicates the 3-level logic. Next comes the procedure. Turn on and off the 3 buttons to indicate the status of a driver present. Buckle off and ignition. Observe for what conditions of the inputs does the red warning light glow and the alarm is set on. Using simulator, build the seatbelt warning system and verify the result. There are 3 inputs placed. First, when the driver is present and the belt is buckled off and the ignition is on, the warning alarm will hit. Secondly, when the driver is present and the seat belt is buckled on and the ignition is on, the warning alarm will not hit. This is the perfect example for this simulation of the seatbelt warning system using basic and NOT gate.